Question 14. Which of the following expresses 2x squared outside of 5 minus x outside of x minus 2 in its simplest form? So the strategy here is to expand the brackets and then collect the like terms. So let's do that. 2x squared multiplied by 5 is equal to 10x squared. 2x squared multiplied by negative x is negative 2x cubed. Negative x multiplied by x is negative x squared. And negative x multiplied by negative 2 is positive 2x. Now, collecting like terms, we have one x cubed term, or one term in x cubed. So it's negative 2x cubed. We have two terms in x squared, so 10x squared minus x squared is positive 9x squared. And then we have 2x on its own. So the answer is option A, negative 2x cubed plus 9x squared plus 2x. Question 21. Which of the following correctly expresses C as the subject of E equals mc squared plus P? So I'm going to start off by swapping both sides of the equation around. So I'm going to write it as mc squared plus P is equal to E. And the reason for that is we want C as the subject of the formula. So it'll be great if we had the C on the left-hand side. Next, let's move the plus P over the other side so it becomes minus P. We treat mc squared as a single term for the time being. So leaving mc squared where it is and leaving the E where it is, this plus P, move it over, it becomes minus P. Always do the opposite of when you move from one side to the other, just do the opposite of what's going on. So if it's positive here, it becomes negative here. Next, let's divide both sides by m. So the m and the m here cancel, so we have c squared is equal to E minus P over m. And finally, to make C the subject of the formula, we take the square root of both sides. So C is equal to the square root of E minus P over m. Notice that the square root goes over the entire fraction, and it's plus or minus since we're taking the square root of a square. And so the answer is option A. Question 28b. Simplify fully 18ab over 3a squared multiplied by c over b. One strategy would be to express this product of two fractions as a single fraction in expanded form. So 18ab multiplied by c can be written as 18 multiplied by a multiplied by b multiplied by c, and the product of the two denominators, 3a squared b, can be written as 3 multiplied by a multiplied by a multiplied by b. That makes it easier to see what you can cancel from the numerator and the denominator. So firstly, the two a's can be cancelled here and here. This b can be cancelled with this b there. 18 over 3 is just 6 over 1, so that can be simplified easily. And so what we're left with is a c in the numerator and an a in the denominator. So this expression simplifies to 6c all over a. Question 5. Which of the following is 12t squared all over 3t times 2w in its simplest form? So I'm going to start off by writing the fraction in expanded form. So the numerator, 12t squared, can be written as 12 times t times t. And the denominator, which is 3 times t times 2 times w, can be written as 3 times 2 times t times w. And because all the terms are multiplied together, we can switch the order of the terms around. So simplifying it further, simplifying the numbers, so 12 over 3 times 2 is just 12 over 6, and t times t over t times w, we can cancel a t from the numerator and a t from the denominator. So we end up with 12 over 6 multiplied by t over w. Now 12 over 6 is just 2, and t over w is just t over w. And because we have a whole number multiplying a fraction, the whole number multiplies the numerator. So we end up with 2t over w. So the answer is option A. Question 21. Which equation correctly shows R as the subject of S equals 800 outside of 1 minus R? Now the first thing to note is that 800 is multiplying this bracket 1 minus R. So I've just written it explicitly as 800 multiplied by 1 minus R in brackets. Next, we'll need to expand the brackets. That means removal of the brackets by multiplying every term inside the brackets by 800. And we get S equals 800, so 800 multiplied by 1 gives us 800. And 800 multiplied by negative R gives us negative 800R. Now we need to make R the subject of the formula. So I'm going to add 800R to both sides, and in doing so, this negative 800R effectively moves over and becomes positive 800R. So we have 800R plus S equals 800, so this 800 here stays intact, it stays where it is. Now we need to subtract S from both sides, so this positive S, you could move that over and becomes negative S, or just subtract S from both sides. So we have 800R, so that stays where it is equal to 800 minus S. So this plus S becomes minus S on this side. And of course we'll need to divide both sides by 800 to have R the subject of the formula. So R equals 800 minus S all over 800. So the answer is option A. Question 29A. Sarah tried to solve this equation and made a mistake in line 2. Copy the equation in line 1 into your working booklet and continue your solution to solve this equation for W. Show all lines of working. So the first line, which is just copied straight from the question, is this equation W plus 4 over 3 minus 2W minus 1 over 5 equals 1. Now our first step is to eliminate the fraction on the left hand side by multiplying each of these terms by 15. Since by multiplying by 15, that'll eliminate the 3 and the 5 at the same time. So we can write it like this. 15 over 3, so that denominator of 3 just gets moved out to here. Outside of W plus 4 minus 15 over 5, so that's this 5 here. Outside of 2W minus 1 equals 15. That's 1 multiplied by 15 equals 15. Now we can simplify the fractions. So 15 over 3 is 5, and 15 over 5 is 3. So the equation becomes 5 outside of W plus 4 minus 3 outside of 2W minus 1 equals 15. So we've eliminated the fractional component of this equation. Next we need to expand the brackets. So just multiplying through, 5 times W is 5W. 5 times positive 4 is positive 20. Negative 3 times 2W is negative 6W. And negative 3 multiplied by negative 1, negative multiplied by negative gives a positive, and that equals positive 3. And this entire left-hand side, of course, equals 15. Now we can collect the like terms. So we have a 5W and a negative 6W there. And we have a positive 20 and a positive 3. That can be combined. So 5W minus 6W is equal to negative W. And positive 20 plus 3 is positive 23, or plus 23, and that equals 15. Now we can subtract 23 from both sides. So we have negative W as the subject of the formula, and that equals 15 minus 23. And 15 minus 23 is equal to negative 8. And if we multiply or divide both sides by negative 1, we have W equals 8. Now, if you have time, it's worth verifying the solution. And we do that by substituting this value of W into the original equation, and then checking that the left-hand side, in fact, equals 1. So the left-hand side is 8 plus 4 over 3 minus 2 times 8 minus 1 over 5. And evaluating that, we get 12 over 3 minus 15 over 5, which equals 4 minus 1. And that equals 1, which equals the right-hand side of the original equation. So therefore, we are confident that W equals 8 is the correct answer. Question 30A. Wind turbines, such as those shown, are used to generate power. In theory, the power that could be generated by a wind turbine is modelled using the equation T equals 20,000 W cubed, where T is the theoretical power generated in watts and W is the speed of the wind in meters per second. So part 1, using this equation, what is the theoretical power generated by a wind turbine if the wind speed is 7.3 meters per second? So this one's straightforward. We just take the 7.3, we substitute it for W, we raise it to the power of 3, so 7.3 cubed multiplied by 20,000 will give us our theoretical power. So T equals 20,000 multiplied by 7.3 to the power of 3, and that gives us 7,780,340 watts. Part 2. In practice, the actual power generated by a wind turbine is only 40% of the theoretical power. If A is the actual power generated in watts, write an equation for A in terms of W. So the equation will be 40% of 20,000 W cubed, since 20,000 W cubed is the theoretical power generated. So A is equal to 40% multiplied by 20,000 multiplied by W cubed. So that 20,000 W cubed comes from here, the theoretical power generated. And 40% of 20,000 is 8,000. So therefore, A, the actual power generated, is equal to 8,000 W cubed. Part 3. Using the graph or otherwise, find the difference between the theoretical power and the actual power generated when the wind speed is 9 meters per second. So using the graph, we locate the 9 on the x-axis, so that corresponds to a wind speed of 9 meters per second, projecting upwards until we strike both curves. We want the difference between this point here, the vertical difference that is, between this point here and this point here. So projecting across from these 2 points, we want the difference on the y-axis. And that works out to be around 8.6 or 8.7 million watts. We could work this out numerically, of course, by determining the theoretical power generated and then subtracting from that the actual power generated. So 20,000 multiplied by 9 cubed minus 8,000 multiplied by 9 cubed, and that gives 8,748,000 watts. Part 4. A particular farm requires at least 4.4 million watts of actual power in order to be self-sufficient. What is the minimum wind speed required for the farm to be self-sufficient? Now the formula for actual power is 8,000 W cubed, which we determined in part 2. 4.4 million watts of actual power corresponds to 4,400,000 watts. So we're going to use the formula 8,000 W cubed. We're going to equate that with 4,400,000 and then solve for W. So 8,000 multiplied by W cubed is equal to 4,400,000. Next, we're going to make W cubed the subject of the formula by dividing 4,400,000 by 8,000. So 4,400,000 divided by 8,000 is equal to 550. And then to find W, we take the cube root of 550. So cube root 550, and we get 8.1932 and so on, rounding that to one decimal place. We get W equals 8.2 meters per second. Part 5. A more accurate formula to calculate the power P generated by a wind turbine is P equals 0.61 multiplied by pi multiplied by r squared multiplied by W cubed, where r is the length of each blade in meters, W is the speed of the wind in meters per second. Each blade of a particular wind turbine has a length of 43 meters. The turbine operates at a wind speed of 8 meters per second. Using the formula above, if the wind speed increased by 10%, what would be the percentage increase in the power generated by this wind turbine? Our first step is to increase the original wind speed of 8 meters per second by 10%. And we accomplish this by multiplying the 8 by 110%, and that gives us a new wind speed of 8.8 meters per second. Our next step is to determine the difference in power generated when the wind speed is 8.8 meters per second versus a wind speed of 8 meters per second. I'm going to use the formula in the question. So the difference in power generated is 0.61 multiplied by pi multiplied by 43 squared multiplied by 8.8 cubed minus 0.61 multiplied by pi multiplied by 43 squared multiplied by 8 cubed. And that equals 600,502.1596 watts. Now to work out the percentage change, we take the difference in power generated and we divide it by the power generated at the original wind speed of 8 meters per second. So 600,502.1596 divided by 0.61 multiplied by pi multiplied by 43 squared multiplied by 8 cubed. Then multiply that by 100 because we want the answer as a percentage, and that equals 33.1%. Question 4. Young's formula below is used to calculate the required dosages of medicine for children aged 1 to 12 years. How much of the medicine should be given to an 18-month-old child in a 24-hour period if each adult dosage is 45 milliliters? The medicine is to be taken every 6 hours by both adults and children. Now the first step is to convert the child's age into years. So 18 months is equal to 1.5 years. We can substitute that into the formula directly. So the dosage is equal to the age of the child in years, so that's going to be 1.5 multiplied by the adult dosage, so that's multiplied by 45 over age of the child in years again, so that's going to be 1.5 plus 12. And calculating that, we have 1.5 multiplied by 45 over 1.5 plus 12, and we have 5 milliliters. However, that's to be taken every 6 hours for 24 hours, so that'll be 4 dosages, so we need to multiply that by 4. So the total is equal to 5 multiplied by 4, and it'll be 20 milliliters. So answer is B. Question 11. Simplify 6w to the power of 4 multiplied by 1/3 w squared. Now one helpful strategy would be to write the expression in expanded form. So putting the multiplication sign between the 6 and the w to the power of 4 and between the 1/3 and the w squared. So this expression can be written as 6 multiplied by w to the power of 4 multiplied by 1/3 multiplied by w squared. Now because all these terms are being multiplied together, that can happen in any order. So let's multiply the numbers first. So 6 multiplied by 1/3 is equal to 2. And w to the power of 4 multiplied by w squared is w to the power of 6, based on one of the index laws, where we add the indices together when you're multiplying two terms with the same base. So the answer is 2w to the power of 6, and that will be option A. Question 26a. Expand 4x outside of 7x to the power of 4 minus x squared in brackets. We need to apply the distributive law here. The term on the outside multiplies each of the terms on the inside separately. So this will be our first line of working out. So 4x multiplied by 7x to the power of 4 minus, so it comes from this minus here, 4x multiplied by x squared. Our next step is to simplify this expression. So 4x multiplied by 7x to the power of 4, you multiply the numbers separately and multiply the pronumerals separately. So 4 times 7 will be 28. X multiplied by x to the power of 4 is x to the power of 5. So the power of this x here is a 1. Likewise with 4x multiplied by x squared, 4 times 1, there's an invisible 1 here, 4 times 1 is 4, and x times x squared is x cubed. And we end up with our solution. Question 26c. Solve the equation 5x plus 1 all over 3 minus 4 equals 5 minus 7x. There's two ways we can start this. You can notice that we have a negative 4 on its own, and we also have a 5 on its own, and we can move that negative 4 over by adding 4 to both sides. The other way we can do this is to multiply each of these terms by 3, which eliminates this denominator of 3 in the first term. So I'm going to do just that. I'm going to multiply each of these terms by 3 to eliminate this denominator first. So we end up with 5x plus 1, since 5x plus 1 over 3 multiplied by 3 will cancel that denominator. Now 4 times 3 is 12, so minus 12. 5 times 3 is 15, and 7 times 3 is 21x. So we have 5x plus 1 minus 12 equals 15 minus 21x. The next thing to note is on the left-hand side we have a plus 1 minus 12, so that can be simplified. So we have 5x minus 11 equals 15 minus 21x. The next thing we need to do is to move the pronumerals to one side and the numbers or the constants over to the other side. So I'm going to move the pronumerals or the terms involving the pronumeral to the left and the constants or just the numbers on their own to the right. So minus 21x or negative 21x, when that's moved over from the right hand side to the left hand side, becomes positive 21x. And negative 11, when that moves to the other side, so from the left to the right hand side, the negative 11 changes and becomes positive 11. It's the same as adding 11 to both sides. Negative 11 plus 11 eliminates the negative 11, but then you need to add 11 to the other side to compensate for that. Now it's just a simple case of combining the like terms. So 5x plus 21x, you get 26x equals 15 plus 11, which equals 26. And of course, dividing both sides by 26, x equals 26 divided by 26. We have, therefore, x equals 1 as the solution to this equation. Now, don't forget, if you've got some time, and try to factor in some time into this, don't forget to verify your solution. If you substitute x equals 1 into the left-hand side and then into the right-hand side, you should find that the left-hand side or the value on the left-hand side should equal the value on the right-hand side. Question 29b. What is the maximum number of standard drinks that a male weighing 84 kilograms can consume over 4 hours in order to maintain a blood alcohol content, BAC, of less than 0.05? And the formula for BAC is BAC for a male equals 10N minus 7.5H over 6.8M, where N is the number of standard drinks, H is the number of hours drinking, and M is the mass of the person in kilograms. So what do we know? We know that M equals 84. We know that H equals 4, and we know that BAC is equal to 0.05 because what we're interested in is to find the number of standard drinks or the maximum number of standard drinks that this person can have while at the same time keeping the BAC less than 0.05. So the strategy here is to substitute in the known values into the formula and then make N the subject of the formula. So 0.05, so that's the BAC, equals 10N minus 7.5 times 4, since 4 is the number of hours, all over 6.8 multiplied by 84. And 84, of course, represents 84 kilograms, the mass of the person. So simplifying this fraction somewhat, we have 0.05 equals 10n minus 30, so 7.5 times 4 is 30, all over 571.2. So we need to multiply both sides by 571.2. So we have 0.05 multiplied by 571.2 equals 10n minus 30. And just simplifying the left-hand side, so 0.05 multiplied by 571.2, and that gives us 28.56 equals 10n minus 30. So we can add 30 to both sides. We have 28.56 plus 30 equals 10n. And simplifying the left-hand side again, we have 58.56 equals 10n, or 10 times n. The next step would be to divide both sides by 10 to make n the subject of the formula. So n equals 58.56 divided by 10, n equals 5.856. So that represents 5.856 standard drinks, but the number of standard drinks needs to be a whole number. Now, if n equals 6, the BAC will be over 0.05. And the question clearly states less than 0.05. So this person cannot consume 6 standard drinks. So we cannot round this number up to 6. So n must be an integer, of course, so it can't be decimal for starters. And we also need to round down to the nearest whole number so that the BAC is kept below 0.05. So therefore, the maximum number of drinks is 5. Question 2. Which of the following is 4x plus 3y minus x minus 5y in its simplest form? So I'm going to suggest a strategy here to answer these questions a little bit more accurately, especially involving simplification in algebra. And that is to write the expression with gaps. So start off with the 4x. Now leave a gap and then write plus 3y. Leave another gap and write minus x. And then leave another gap and write negative 5y. So this is especially important if you're not feeling confident with algebra. This enables you then to collect the like terms far more effectively. So let's look at the like term involving the pronumeral x. So we have 4 of these x's minus x. When it's a pronumeral on its own, it actually means 1x. So 4x minus 1x is equal to 3x. And the y's, or the like terms involving the pronumeral y, we have positive 3y, or plus 3y, minus 5y. So 3 minus 5 is negative 2y. And looking at the options available, it's going to be option A. Question 11. Which of the following is 3x to the power of 0 plus 5x in its simplest form? So to help answer this question, I'm going to expand this expression by including the multiplication symbols. So 3x to the power of 0 is just 3 multiplied by x to the power of 0 plus 5x. So that's really just 5 multiplied by x. Now, index laws. Anything to the power of 0, apart from 0 itself, of course, but anything to the power of 0 is 1. So this is equal to 3 multiplied by 1 plus 5 multiplied by x, and we can now simplify this. So 3 times 1 is just 3, and 5 times x is 5x. So 3 plus 5x is the expression in simplest form, option D. Question 23. The number of standard drinks in various glasses of wine is shown. A woman weighing 62 kilograms drinks 3 small glasses of white wine and 2 large glasses of red wine between 8 p.m. and 1 a.m. What would be her blood alcohol content BAC estimate at 1 a.m. correct to 3 decimal places? Now, in order to answer this question, the formula does need to be given. Now, in the old syllabus, the formula was in the formula sheet, so that would have been it there. Okay, so I've just copied it out here in the question. In the current syllabus, the formula is generally given to you, so it's just more a matter of how do you use the formula. Okay, so let's do that. Now, the M is the mass, so we know that M is 62. H is the number of hours drinking, and so I might just write these down. So M is equal to 62. H is the number of hours drinking, and that's between the hours of 8 p.m. and 1 a.m. So 8, 9, 10, 11, 12, 1, there's 5 hours, so H is 5. But the N is an interesting one. So the number of standard drinks, and this is where we need to consult the table. So 3 small glasses of white wine. So we're using this column here, and there's 3 of those. And we have 2 large glasses of red wine. Okay, so 2 large glasses of red wine, so 2 of those. So N is equal to 3 lots of small glasses of white wine, so that's 0.9, plus 2 drinks, 2 large glasses of red wine, so two of those drinks, and each one of those is 1.5 standard drinks, so that needs to be in brackets. Now let's enter that into the formula, so substitute those values into the BAC formula, and let's see what we get. Okay. So 10n, actually I might just enter it in as a fraction. Yep, I might just brighten that a little bit. Yeah, that's better. Okay, so 10n, so that's the n there. So 3 multiplied by 0.9 plus 2 multiplied by 1.5, close brackets. Okay, minus 7.5h, so 7.5 multiplied by the number of hours drinking, so that's 5, over 5.5 multiplied by her mass, which is 62 kilograms, and we get 0.0572 or 0.057 to 3 decimal places. So 0.057 dot dot dot, and answer is option D. Question 24. Consider the equation 2x on 3 minus 4 equals 5x on 2 plus 1. Which of the following would be a correct step in solving this equation? Now, typically when solving an equation that has a variable or an unknown variable on both sides of the equal sign, I guess it's not necessarily the only way to think of this, but generally convention, or by convention, we like the pronumerals on the left-hand side and the constants eventually migrating over to the right-hand side. So leaving the 2x over 3 where it is, okay, the negative 4 probably should move over to the other side. So equals 5x over 2 plus 1. So that's the plus 1 there. But negative 4, when it moves over to the other side, becomes positive 4. Okay. So think of the opposite of left is right. The opposite of minus 4 is plus 4. So 2x over 3 equals 5x over 2 plus 1 plus 4 is just plus 5. And in fact, there's only one of these options that has a plus 5 in it. There's a 2x over 3, which is there, so that's on the left-hand side. 5x over 2 on the right-hand side. 5x over 2 on the right-hand side. I think we can safely say it's option B. Question 26b. Clark's formula is used to determine the dosage of medicine for children. So you've got dosage equals weight in kilograms multiplied by adult dosage all over 70. The adult daily dosage of a medicine contains 3,150 milligrams of a particular drug. A child who weighs 35 kilograms is to be given tablets, each containing 525 milligrams of this drug. How many tablets should this child be given daily? So this is just an example of just applying the formula directly. Okay, we have the weight in kilograms, so that's 35. So I might just write them there. We have the adult dosage, okay, which is 3,150. Okay, so let's work out what the dosage is that's required for this child. And we also know that each tablet is 525 milligrams. So it's how many tablets should this child be given daily? So dosage, okay, is equal to 35, okay, 35 kilograms multiplied by 3,150 milligrams of the drug over 70, okay, and that gives us 35, actually I'll enter in as a fraction directly, 35 multiplied by 3150 over 70, and we get 1575 milligrams. Okay, 1575. Now, the number of tablets, okay, so is equal to 1575 milligrams. That's the total dosage. But each tablet is 525 milligrams. So dividing that by 525, okay, and we get 3. So the answer is 3 tablets. Question 28D. The formula C equals 5 over 9 multiplied by F minus 32 in brackets is used to convert temperatures between degrees Fahrenheit F and degrees Celsius C. Convert 3 degrees C to the equivalent temperature in Fahrenheit. So this question is around rearrangement or rearranging the formula to make F the subject. So let's start off by substituting 3 for C in the formula, and then we'll rearrange it. So 3 is equal to 5 over 9 multiplied by F minus 32. Okay. Now, rather than multiplying by 9 and dividing by 5, you can do this actually in one step. So this number here, 5 over 9, or this fraction 5 over 9, is being multiplied by F minus 32. We could move this 5 over 9 over to the other side, okay, and we could do it this way. So 3 divided by 5 over 9 is equal to F minus 32. Now we'll add 32 to both sides. So this negative 32 will move over to the other side and becomes positive 32. So 3 divided by 5 over 9 plus 32 is equal to F. Okay, so just evaluating the left-hand side. Okay, so 3 divided by 5 over 9 plus 32, and we get 37.4. degrees Fahrenheit. So therefore 3 degrees Celsius is equal to 37, actually I'll just fix that, 37.4 degrees Fahrenheit. Question 30D. Claire is driving on a motorway at a speed of 110 kilometers per hour and has to brake suddenly. She has a reaction time of 2 seconds and a braking distance of 59.2 meters. Calculate her stopping distance. Now, any kind of stopping distance question, advisable to draw a number line. And stopping distance is composed of 2 parts. Okay, you have the reaction distance, and then you have the braking distance. And the sum of those two gives you then the stopping distance. Now, we already have the braking distance given, which is 59.2 meters. But we don't know what the reaction distance is. So once we've got that, we can then go on to calculate the total stopping distance. So the reaction distance is in meters, 110 kilometers per hour for 2 seconds. So let's convert 110 kilometers per hour into meters per second. And there's a bit of a shortcut here. Okay, if you divide that by 3.6, that gives you the speed in in meters per second. So 110 divided by 3.6, and you get 5 recurring, which is 30 and 5 on 9. And that's meters per second. But just for your benefit, just so you can see, for those of you, if you find that a little bit confusing, 110 kilometers per hour, okay? If you multiply that by 1,000, okay, that gives you the number of meters. So that's 110,000 meters per hour. An hour is 3,600 seconds. So if you divide that by 3,600, you then get the same answer. So this just is a bit of a time saver. Okay, so that's meters per second. So the reaction distance is equal to the speed in meters per second multiplied by the number of seconds. So that's the distance is equal to speed multiplied by time. And that's for 2 seconds. So I might just multiply my previous answer here by 2. And we get 61 and 1/9 of a meter. So the stopping distance, okay, is equal to the reaction distance. I might just do that first. 61 and 1/9, so we kept it in exact form, plus the braking distance, 59.2. Okay, so I'm just going to again use my previous answer, and I get 120.31. And I'll just round it to 2 decimal places, and that's the approximate. That's the stopping distance correct to 2 decimal places. Question 2. Which of the following equations has x equals 5 as the solution? Now we could either use substitution method and substitute the 5 for x and maybe check each one. 5 minus 5 is certainly not 10, so can't be A. Again, 5 minus 5 is not equal to 10, that's 0, so it's not B. 5 divided by 2, well, that's certainly not 10. 2 times 5, that's certainly 10. Answer is D. Question 5. Which expression is equivalent to 2 outside of 3x minus 4 plus 2? So if we expand the brackets, okay, 2 times 3x is equal to 6x. 2 multiplied by negative 4 is negative 8. And then we're just adding 2 at the end. Collecting the like terms, okay, 6x minus 8 plus 2, negative 8 plus 2 is negative 6. Answer C. Question 10. Caroline drinks 2 small bottles of wine over a 3-hour period. Each of these bottles contains 2.3 standard drinks. Caroline weighs 53 kilograms. What is her approximate blood alcohol content, BAC, at the end of this period? Now, in order to be able to answer this question, we do require a formula from the formula sheet. And this is an older formula sheet, so from a previous syllabus. So I might just write this down. So BAC female is equal to 10N minus 7.5H over 5.5M. So N is the number of standard drinks, H is the number of hours drinking, M is the mass of the person. So let's substitute in some of the details, okay, some of the data into this question, and let's evaluate it. So 2 small bottles of wine over a 3-hour period. Each of these bottles contains 2.3 standard drinks, and there's 2 of them. So 2 times 2.3 minus 7.5 times H. Now H is the number of hours drinking, so it's over a 3-hour period. So it's multiplied by 3 over 5.5 multiplied by her mass, which is 53 kilograms. So entering in that expression in the calculator. So 10 multiplied by 2 multiplied by 2.3. So since each of these bottles of wine is 2.3 standard drinks each, so times 3 over 5.5 multiplied by 53, and we get 0.081 or 0.0806. So rounding that to 3 decimal places, it's option A. Question 24. Which of the following correctly expresses Q as the subject of E equals IR plus Q over C? First thing, let's move the IR over to the other side. So E minus IR is equal to Q over C. Secondly, let's multiply both sides by C. So this is Q divided by C. Moving C to the other side implies multiplication. So E minus IR. And notice that the E minus IR must go in brackets because we're multiplying the C by both E and minus IR. okay, and that's equal to Q. Lastly, we need to expand the brackets. So C times E, okay, is CE. C times minus IR or negative IR is equal to CIR, and that's equal to Q. And the expression that closely matches that, CE minus CIR, is option B. Question 26b. Simplify 8x to the power of 4y over 24x cubed y to the 5. So the way we can do this is to separate out all the components. So numbers first, multiplied by x to the 4 over x cubed, multiplied by y over y to the 5. And we can start cancelling things out. 8 on 24 can be simplified. So if you want to do that on your calculator, you can simplify it there, and that's 1/3. Multiplied by, now you have x to the 4 on x to the 3. So we start with the lower number and subtract it from the higher number. So that disappears, in fact, altogether, and that just becomes a 1, so that just becomes x. Okay, so x over 1, in fact. And y, that's actually y to the power of 1. Okay, and 5 is the larger number, so we can cancel out the y to the power of 1, and then the y to the 5 becomes y to the 4. So this becomes 1 on 3 times x on 1 times 1 on y to the 4, and this can all be combined together into a single fraction. 1 times x times 1 is just x, over 3 times 1 times y to the 4 is just 3y to the power of 4. Question 2. A car is travelling at 95 kilometers per hour. How far will it travel in 2 hours and 30 minutes? So each hour we're covering 95 kilometers. So it certainly cannot be option A, and it cannot be option B. So it has to be more than twice 95 kilometers. 2 hours and 30 minutes is 2.5 hours worth of travel. So 95 multiplied by 2.5 hours, and we get 237.5 kilometers. Option D. Question 7. It is given that I equals 3 on 2 mr squared. What is the value of I when m equals 26.55 and r equals 3.07, correct to 2 decimal places? So this is just direct substitution, and let's just substitute in the known values. So I is equal to 3 over 2 multiplied by m, and m happens to be 26.55, multiplied by r squared, so that's 3.07 squared. So that's what I'm going to enter in now in the calculator. So 3 on 2, I'm writing it as is, so as I've written it, 26.55 multiplied by 3.07 squared, and we get 375.35, okay, to 2 decimal places. Option A. Question 9. What is the value of x in the equation 5 minus x over 3 equals 6? Now there's 2 ways we can do this. Either you can substitute in each of these 4 values into the equation and see that it equals 6, or we can just solve the equation, and that's probably perhaps the easier thing to do. Let's multiply the right hand side by 3. So that's going to be 5 minus x is equal to 3 times 6, which is 18. So let's move 5 over to the other side. So negative x is equal to 18 minus 5. So negative x is equal to 18 minus 5, which is 13. Therefore, x is equal to negative 13 if you multiply both sides by negative 1. So the answer is 9A. Question 19. Young's formula shown below is used to calculate the dosage of medication for children aged 1 to 12 years based on the adult dosage, where D equals the dosage for children aged 1 to 12 years, Y is the age of the child in years, and A is the adult dosage. A child's dosage is calculated to be 20 milligrams based on an adult dosage of 40 milligrams. How old is the child? Now, if you like, rather than wasting time trying to rearrange the formula, this is a multiple choice tactic that you can use. You can substitute the responses in the original equation, okay, and what you should hope for is that one of these should give you an answer of 20 milligrams. So let's try them. Okay, let's try the first one. Okay, so 6 times 40 over 6 plus 12, and we don't get 20. Let's try the next one. Okay. 8 plus 40 over 8 plus 12, and we get 16, but we want 20 as the answer. Let's try 10. 10 times 40 over 10 times 12, and we're getting 18.18, but we still want 20. Now, but we are getting closer. So let's try 12 times 40 over 12 plus 12. The answer is 20, and that equals 20 there. So the answer is option D. Question 27E. Reese is drinking low alcohol beer at a party over a 5-hour period. He reads on the label of the low alcohol beer bottle that it is equivalent to 0.8 of a standard drink. Reese weighs 90 kilograms. And the formula is provided here because in the older syllabus, or in the previous syllabus, the formula was given in a formula sheet. So I've provided it here in the question. What is the maximum number of complete bottles of the low alcohol beer he can drink to remain under a blood alcohol content, BAC, of 0.05? So what we need to do is solve this equation somehow, where N is the number of standard drinks, H is the number of hours drinking, and M is the mass of the person drinking. So this is the formula for the BAC for a male. So we want the BAC to be 0.05. Okay, so I might just do it here, 0.05, okay, is equal to 10N. So we need to work out how many standard drinks that's going to be equivalent to in order to maintain 0.05, minus 7.5H. H is the number of hours drinking, so that's multiplied by 5 over 6.8 M. So that's 6.8 multiplied by Reese's mass. So what we can do now is just clean this up a little bit. Okay, so we might evaluate some of these values. So 0.05 is equal to 10N minus, now 7.5 multiplied by 5 is 37.5 over 6.8 multiplied by 90. And that's 612. Now we need to solve for N. So how many standard drinks is that? So let's make N the subject of the formula. So let's multiply 0.05 by 612. Okay, so 0.05 multiplied by 612 is equal to 10N minus 37.5. Now we can add 37.5 to the other side, so this minus 37.5 becomes a plus, multiplied by 612 plus 37.5 is equal to 10N. Okay, we might as well evaluate the left-hand side since before it gets too out of hand. So 0.05 multiplied by 612 plus 37.5, and we get 68.1 is equal to 10n. And that means that n is equal to, we divide that by 10, is equal to 6.81 standard drinks. Just ran out of space there. But we know that each bottle, so go back to the question, is 0.8 of a standard drink. So how many bottles is this? 6.81 standard drinks. Each bottle is 0.8. So the number of bottles this corresponds to is equal to the number of actual standard drinks, 6.81. Now each bottle is 0.8 standard drinks. Okay, so 6.81, okay, divided by 0.8, and we get 8.5125. Okay. Okay. But the question asks for what is the maximum number of complete bottles, and that's the key word. If you don't see that word there, you don't take into account that word, you'll be probably might be unlucky and get the answer wrong, in fact. So that's really the same as saying 8 complete bottles. So 8 complete bottles would keep Reese slightly under 0.05. To be at exactly 0.05, he would have to drink 8.5125. Okay, so this answers the question. Question 28D. Make y the subject of the equation x equals the square root of yp minus 1. So we need to isolate the y. It needs to be on its own. So maybe the first thing I'll do is maybe swap the two sides around in the equation. The reason why is because I like the subject of the formula to be on the left hand side. So why don't we start off with that? So square root of yp minus 1 is equal to x. Next thing I'm going to do is I'm going to square both sides, because it's kind of like you're trying to free this variable y. It's sort of like trapped, sort of under the square root there. So let's do that. So that's yp minus 1 is equal to x squared. Okay, so that's squaring both sides. Now we need to basically move the terms that are furthest away from y, and the term that's the furthest away is the -1, so we're going to add that to the other side. Okay, so the minus 1, we move it over, becomes plus 1. So yp is equal to x squared plus 1. And lastly, because y is being multiplied by p, and we want p over the other side. So in order to move p over the other side, we need to do the opposite of what p is doing now, which is multiplying y. So we're going to divide the right hand side by p. So it's going to be x squared plus 1 over p. Question 2. What is the value of 3x to the power of 0 plus 1? If we expand this, adding in the multiplication symbol, 3x to the power of 0 is just 3 times x to the power of 0 plus 1. Now, x to the power of 0, anything to the power of 0, is 1. So that's equal to 3 times 1 plus 1, which is equal to 3 plus 1, since 3 times 1 is 3, and that's equal to 4. So it's option D. Question 16. Which expression is equivalent to k squared over 10 divided by 5 over k? First thing we do, change the division into a multiplication, and we invert the second fraction. Then we just multiply the numerators together, and then multiply the denominators together. So we end up with k cubed over 50. K cubed over 50, option D. Question 25. Which of the following expresses V as the subject of K equals half mv squared? So I'm going to start off by writing the equation a little bit differently. So mv squared, that's mv squared on 2, which is the same as half mv squared. Let's multiply both sides by 2, move the 2 over, it becomes 2k is equal to mv squared. Now we divide both sides by m, and it's the same as moving m under the 2k, so 2k over m is equal to v squared. Lastly, we take the square root of both sides, and because we're taking the square root of both sides and we're going to make v the subject, it becomes plus or minus. So plus or minus 2k over m is equal to v. So can't be option D, can't be option B. Plus or minus 2k over m looks like option A. Question 26b. Clark's formula, given below, is used to determine the dosage of medicine for children. For a particular medicine, the adult dosage is 325 milligrams and the correct dosage for a specific child is 90 milligrams. How much does the child weigh to the nearest kilogram? So we know the dosage for this child is 90, so I'm just going to write the numbers above each of the variables. We know that the adult dosage is 325, so I'm just going to write it there. We need to solve for weight in kilograms. Let's call it x. Okay, so substituting in the values, we have 90 is equal to x multiplied by 325, and all that is being divided by 70. Let's move the 70 over by multiplication. So the opposite of division is multiplication. 90 times 70 is equal to x multiplied by 325. Now let's move the 325 over. We have 90 multiplied by 70. I'm going to put that in brackets. Divide that by 325 is equal to x. So 90 multiplied by 70. Divide that by 325. And we get x is equal to 19.38. But we need the answer to the nearest kilogram, so therefore x is equal to 19 kilograms. Question 28b. Solve the equation 2x over 5 plus 1 is equal to 3x plus 1 all over 2, leaving your answer as a fraction. So the first thing to notice is we have a combination of fractions and whole numbers, and the fractions have different denominators. So before we can equate fractions and whole numbers together, why don't we express them all with the common denominator first? Then we can go from there and eliminate that denominator. So we end up with hopefully just whole numbers and no fractions that we're dealing with. So we can use a common denominator of 10 because 5 can divide 10, 1 can divide 10, and 2 can also divide 10. So 2x over 5, okay, we're going to express this using an equivalent fraction. So 2x over 5 on a denominator of 10. So we're going to multiply this first fraction by 2 over 2. 1 can be expressed with the denominator of 10. That's just 10 over 10. So that's going to be multiplied by 10. And 3x plus 1 all over 2, we're going to express this with a denominator of 10. We're going to multiply this entire fraction by 5 over 5. So 2x over 5 is 4x over 10 plus the number 1 is really just 10 over 10. So multiplying that by 10 on 10, you get 10 over 10, which is just 1, is equal to 3x plus 1 over 2. So that's the same as 5 outside of 3x plus 1 all over 10. So all three terms now are expressed with a common denominator of 10. So we can now eliminate that denominator altogether. So what this allows us to do is to write it this way. 4x plus 10 is equal to 5 outside of 3x plus 1. Notice, no denominator, gone. That's the beauty of common denominators. Once you have a common denominator, you can just eliminate them. So, moving on. Let's expand this bracket. So the next line will be 4x plus 10 is equal to 5 times 3x, that's 15x. 5 times 1 is 5. Now this looks like a regular two-step equation. Let's collect the like terms, and okay, let's move the x's to sort of to one side, to the left, and move the constants, these numbers or constants, over to the right-hand side. So 4x, the 15x moves over, it becomes 4x minus 15x. The plus 5 is on the right, the correct side, on the right side there. And it is on the right side, so pun intended. 5 minus 10. Okay, so moving the plus 10 over, it becomes minus 10. Now 4x minus 15x is negative 11x. 5 minus 10 is negative 5. Therefore, x is equal to negative 5 over negative 11. And a negative divided by a negative just makes it positive. So therefore, x is equal to 5 over 11. Now, if you have a spare moment, you want to check and make sure that this actually works. So I might just do this on this side here. So this is a check. Okay, let's work out the value of the left-hand side. Okay, so what we'll do is we'll put in our value that we just came up with. So 5 over 11, shift, store. Now x just above the bracket there. Okay, so now we've put that in the memory location x. Now let's type in, using the alpha key, the left-hand side. So 2 alpha x over 5 plus 1, and we get 13 on 11. Let's check the right-hand side. Okay, so 3 alpha x plus 1 over 2, and we get 13 on 11. Hopefully, if you've done that correctly, we know then that this is the correct answer. So we're happy with that. Question 28E. Sophie is driving at 70 kilometers per hour. She notices a branch on the road ahead and decides to apply the brakes. Her reaction time is 1.5 seconds. Her braking distance, d meters, is given by d equals 0.01 v squared, where v is the speed in kilometers per hour. What is Sophie's stopping distance to the nearest meter? Now the first thing here to note is that stopping distance is really the sum of reaction distance plus braking distance. So let's work out the reaction distance first. First of all, we need to convert her speed from kilometers per hour into meters per second. And a quick way to do that is to divide it by 3.6. Nice little shortcut to use. Okay, so dividing that by 3.6 gives us 19. In fact, I could convert this into a mixed numeral, 19 and 4/9 meters per second. So her actual distance then, so reaction distance, is equal to her speed in meters per second multiplied by the number of seconds it takes for her to react, which is 1.5 seconds. And what we'll do here, okay, so I've got the previous answer. I'm just going to multiply that by 1.5. And we get 29 1/6 of a meter. Now let's work out the braking distance. And we need to use the formula. Okay, so D is equal to 0.01 v squared. V is her speed in kilometers per hour. Okay, and just entering in that to the calculator. So 0.01 multiplied by 70 squared. And we get 49 meters. So the stopping distance is a combination or the sum of 1 and 2. The answers 1 and answer number 2 together. So stopping distance is equal to 29 1/6 plus 49. Adding those together. So you get 78.166. Okay. But we need to answer to the nearest meter. So we've definitely specified more than enough decimal places there. So that's just going to be 78 meters, correct to the nearest meter. Question 11. Which of the following correctly expresses y as the subject of the formula 3x minus 4y minus 1 equals 0? So what we're going to do, we're going to leave the negative 4y alone. Okay. We're going to move the 3x over, so it becomes negative 3x, and we're going to move the negative 1 over to the other side, it becomes positive 1. Next thing we're going to do is we're going to divide by negative 1. So 4y is equal to 3x minus 1. Okay, so by dividing by negative 1 or multiplying by negative 1, it switches the signs of all the terms on the other side. And then lastly, we're going to divide everything by 4. So 3x minus 1 over 4. And that'll be option C. Question 28. The formula below is used to calculate an estimate for blood alcohol content, BAC, for females. The number of hours required for a person to reach 0 BAC after they stop consuming alcohol is given by the following formula. The number of standard drinks in a glass of wine and a glass of spirits is shown. Hannah weighs 60 kilograms. She consumed 3 glasses of wine and 4 glasses of spirits between 6:15 p.m. and 12:30 a.m. the following day. She then stopped drinking alcohol. Using the given formulae, calculate the time in the morning when Hannah's BAC should reach 0. So let's just quickly recap this formula. The BAC formula, N is the number of standard drinks, H is the number of hours drinking, and M is the body mass of the person. So let's work out first of all how many standard drinks were consumed. So she consumed 3 glasses of wine, 3 times 1.2 standard drinks per glass, plus 4 glasses of spirits, and a glass of spirits is 1 standard drink, so we can just add 4 to that. Okay, so 3 times 1.2 plus 4 is 7.6. Now let's work out the number of hours drinking. Okay, we've got 12:30 a.m. Okay, is the end. 6:15 p.m. is the beginning. So you could do it in various ways. So you could work out 6:15 p.m. to 11:15 p.m. Yeah, and that's equal to 5 hours. And then from 11:15 p.m. to 12:30 a.m. is 1 hour and 15 minutes. Okay. If you add those two together, so total time is equal to 5 hours plus 1 hour and 15 minutes, and that equals 6 hours and 15 minutes. Now, this needs to be converted into decimal. Okay, and we can use the DMS button here. Okay, 6 hours, 15 minutes. So if you don't know it offhand, so that's going to be 6 1/4 hours. Okay, but you could use this button here. So if you have a mental blank, 6.25 hours. Okay, so that gives us our H in the formula. Now let's apply the BAC formula. Okay, and that's equal to 10 times N, which is the number of drinks, which was 7.6. Okay, minus 7.5 H, which is the number of hours drinking, all over 5.5 multiplied by Hannah's mass, which is 60 kilograms. So 10 times 7.6 minus 7.5 times 6.25 over 5.5 multiplied by 60. And we'll press the SD button there, so that's equal to, right, you can see that there. Right, I'm going to write a few decimal places, 0, 8, 8, 2, 5, 7, 5, dot, dot, dot. Okay, as long as you show 6 or 7 decimal places, the rounding will be fine. Okay, at the end, and you'll get the right answer. Okay, now to get the final mark, the time, or the final 2 marks really, the time to achieve a BAC of 0. So the hours time needed for 0 BAC, okay, is equal to, and we're going to use this formula here, so BAC 0.088255 over 0.015. Okay, 0.0882575 over 0.015. Okay, and if you want, we can press the DMS button, and that gives us 5 hours and 53 minutes. Okay, probably write it a little bit smaller because we're not meant to write in the area there. Yep, 5 hours and 53 minutes. And now to work out what time her blood alcohol will reach 0, 5 hours and 53 minutes, we add that on to the time she stopped drinking, which is 12:30 a.m. Okay, so 5 hours, okay, 53 minutes plus 12:30 a.m. Okay, you could also use the DMS button here for adding on time or adding time. 5 hours, 53 minutes plus 12:30 a.m. Now in 24-hour time, and we should be using 24-hour time, that's 0 hours, 30 minutes. And we get 6:23 a.m. So a little bit clearer there. a.m. And that's the time, or the approximate time, when her blood alcohol content will be 0. Question 3. The distance between Bricktown and Koala Creek is 75 kilometers. A person travels from Bricktown to Koala Creek at an average speed of 50 kilometers per hour. How long does it take the person to complete the journey? So this is a question that relates to distance, speed and time, and you probably might have seen this before. Remember well, if you haven't seen it, well, good way to sort of introduce it, I guess. Distance, speed and time. You might have seen this triangle before. So what this means is that distance is equal to speed multiplied by time. So we want how long. So this means that we want time. So the way this works is if you cover the t, okay, so imagine you cover the t, t is equal to distance over speed. Okay, so time is equal to distance over speed. Now the distance is 75 kilometers over a speed of 50 kilometers per hour. Okay, so 75 divided by 50, and we get 1.5. Okay, and 1.5 hours means 1 hour and 30 minutes. Okay, so it's going to be option C. Question 13. When Jake stops drinking alcohol at 10:30 p.m, he has a blood alcohol content BAC of 0.08375. So I might actually just underline that. The number of hours required for a person to reach 0 BAC after they stop consuming alcohol is given by the formula time equals BAC over 0.015. At what time on the next day should Jake expect his BAC to be 0.05? So what we're interested in is just how much time or how many hours it's going to take rather than dropping to 0. So in other words, 0.08375 to 0, just dropping to 0.05. So let's work out the drop first. So 0.08375 minus 0.05. Okay, so let's enter that in there in the calculator. 0.08375 minus 0.05. So we get, I might just write this down, 0.03375. So we want to work out how long it's going to take Jake's BAC basically to drop to 0 from this level here. Right, so now let's use the formula. So time is equal to 0.03375 over 0.015. Okay. So 0.03375 over 0.015, and we get 2¼ hours. Okay, so if you want to press the degrees, minutes, seconds button, 2 hours and 15 minutes. So what time in the morning is that? So stops drinking at 10:30 p.m. and we're going to add 2 hours and 15 minutes. So that's going to be, well, 10:30 p.m. Plus 2 hours and 15 minutes. It's going to be 12:45 in the morning. So option A. Just quickly, if you ever get stuck and you think, oh, how did you work that out? You know, quickly, 10:30 p.m. Right now, if you want to, you could use 24-hour time. Okay, so I might just write that up here. Right, 22:30. Okay, plus 2 hours and 15 minutes, so that's 0215. Okay, if you add those together, 22 hours 30 minutes, so that's 10:30 p.m. plus, okay, 2 hours and 15 minutes, we get 24:45. Well, 24 hours means we've gone into the next day. If we subtract 24 from that, we get 0:45. So that's midnight, 45 minutes past midnight. Question 9. A student is thinking of a number. Let the number be x. When the student subtracts 8 from this number and multiplies the result by 3, the answer is 2 more than x. Which equation can be used to find x? Subtracting 8 from this number and multiplying the result by 3 is equivalent to 3 multiplied by x minus 8. Notice that the x minus 8 is in brackets because that needs to occur first, based on the wording of the problem. Now this is equal to 2 more than x. Now 2 more than x is just x plus 2 in the language of algebra. And these two algebraic expressions are equal. So combining those two, the answer is option C. 3 outside of x minus 8 is equal to x plus 2. Question 29. Solve x plus x minus 1 over 2 equals 9. The first step is to eliminate the fraction by multiplying every term by 2. It helps to enclose the numerator in its own set of brackets. Now x multiplied by 2 is 2x. X minus 1 all over 2 multiplied by 2 is x minus 1, and they're enclosed in brackets. 9 multiplied by 2 is 18. Next, expand the brackets. And there's not much that needs to be done there apart from just removal of the brackets. So 2x plus x minus 1 is equal to 18. Collecting the like terms, 2x plus x is 3, and adding 1 to both sides, 18 plus 1 is 19. Finally, dividing both sides by 3, we have x is equal to 19 over 3. Now we can check the solution by substituting 19 over 3 for x in the left-hand side of the equation. So checking the left-hand side equals 9. 19 over 3 plus 19 over 3 minus 1 all over 2. Evaluating that expression does equal 9, which equals the right-hand side. So we are confident that this is in fact the correct answer.